Good day, engineers. Para sa video natin ngayon is sasagutan natin yung item B nung sample problem from our previous video. So, yung item B kasi that is for square footing which has a dimension of 3.5 meter by 3.5 meter and yung water table niya is at a depth of 1.5 meters below the base of the footing. So, kung i-interpret natin yung drawing nung or yung i-interpret natin yung problem itself on a drawing. So, ito siya. So, we have here on the top view nung footing natin. So, meron siyang dimension na 3.5 by 3.5. Then, we also have here same values of the unit weight for dry soil and the unit weight for saturated soil. At ang sabi dun sa problem natin, yung water table is at a depth 1.5 meters from below the base of the footing. Then, may matitira tayong 2 meters na saturated soil for a depth na 3.5 meters din kasi nga susukat tayo ng same height of the base para dun sa unit weight natin on the third term of the bearing capacity equation. So, syempre square na to. So, ang mangyayari is mag-iiba na yung gamit natin na equation for our soil bearing capacity. So, ang gagamitin na natin dito will be the value QU is equal to the C 1.3 CNC plus the value QNQ plus 0.4 gamma B and gamma. So, yan na ngayon yung kukunin natin na equation. Ngayon, ang magpapalit lang from our previous video will be yung Q, yung gamma, and yung B. But the rest is still the same. Yung cohesion natin, yung NC, yung N gamma, and NQ is pare-pares lang. Yung bearing capacity factors natin. So, we first solve for the surcharge or the overburden pressure. So, overburden. So, that will be Q is equal to, so kung ano man yung nasa taas ng footing na soil natin, or kung ano yung nasa taas na nakapatong, so that will be yung soil lang na dry, which is having a height of 1.4. So, that will just be equivalent to 16 times 1.4. So, now we have here our overburden pressure equivalent to a value 112 over 5. That is in kilopascals. Next, yung base naman natin or yung B on the third term will be equivalent to 3.5 meter since 3.5 meter siya kasi square yung footing natin. So, wala namang least dimension sa kanilang dalawa and they are both equal. So, we will just use the 3.5 meter. Ngayon, yung part naman ng unit weight gamma from the third term of the equation is kukunin natin using the gamma average kasi nga there are two types of soil na na-cover yung height na 3.5 meter which is yung same as our width of the footing which is 3.5 meters din. So, that means gagamit tayo dito ng gamma average which is para siyang yung Varigdon's theorem. So that will be gamma average, which is equivalent to, so that will be yung first soil which is dry, ito. So may height yun na 1.5 and ang unit weight nun is 16. So that will be 16 times 1.5. Then i-add natin dito yung unit weight nung saturated soil, pero gagawin natin siyang effective unit weight. So that will be 19 minus 9.81 times yung height ng soil, which is 2 meters. Then this will be divided dun sa total height, which is 3.5 meters. So from this equation, we will have a value of the gamma average, which is equivalent to 2,119 over 175. So ito na ngayon yung unit weight or gamma av for the third term equation, which is yung ito. So since pares lang yung values ng bearing capacity factors nito coming from our previous sample problem on the item A, kasi we use Terzaghi's table. So for the Terzaghi's table, so from our previous sample problem, yung nakuha natin doon na bearing capacity factors are NC, which is equal to 17.7, tapos yung NQ, which is equivalent to 7.4, and yung N gamma, which is equivalent to 5. So ngayon, we are now ready to substitute these values to our ultimate bearing capacity equations. So that will be QU is equal to 1.3 times yung cohesion natin, which is 20, times the NC, which is 17.7, plus the Q na na-compute natin kanina, which is 112 over 5, times yung NQ natin, which is 7.4, plus that is 0.4 times yung gamma na na-compute natin, which is 2,119 over 175, times yung B natin, which is 3.5, then yung N gamma natin, which is 5. So calculating these values, we will have an ultimate bearing capacity equivalent to 17,768 over 25. So this is in kilopascal. Ito na ngayon yung sagot natin for the part ng ultimate bearing capacity using the Terzaghi's table for the bearing capacity factors. So doon naman sa part ng alternative equation, kunin lang natin yung mga bearing capacity factors na na-compute natin, since wala namang magbabago doon from our previous sample problem, kasi nga same value of the angle of internal friction lang, which is yun yung kailangan to compute for the bearing capacity factors. So naka-compute tayo doon. So lagay lang natin, this is for alternative equation. So that will be, yung NQ na na-compute natin doon is equivalent to 6.3994. Yung NC is equal to 14.8347. Then yung N gamma is equivalent to 5.3863. So to compute, we have to substitute the same value of C. So that is 1.3 muna times C, which is 20, times the NC, which is 14.8347, plus Q, which is 112 over 5, times 6.3994 na NQ. So, itong mga bearing capacity factors, as I repeat, galing siya from our previous sample problem since hindi naman nagbago yung angle of internal friction natin. So, plus 0.4 times the gamma 2119 over 175 times B, which is 3.5, times the NC, which is 5.3863. So from this equation, we will have a value QU, which is 620.3573. So this is in kilopascals. So ito na ngayon yung ultimate bearing capacity natin for Terzaghi's equation using the alternative equation for the bearing capacity factor. Then, yung last na record natin is by using the Meyerhof's equation. So, dito na lang natin siya i-solve. So, that will be for Meyerhof's. So, sa Meyerhof's equation, ang papalitan lang natin dyan is yung mga shape and depth factor. Yung inclination factors kasi, automatic, that will be 1.0 since nasosolve natin yung equation using Terzaghi's equation, and we know from Terzaghi's equation that this equation is derived with the assumption that the load is vertical. So, palitan natin yung mga shape and depth factors niya. So, yung KP, yung passive earth coefficient for determining the shape and depth factor is hindi magbabago kasi ang required lang naman natin dito is phi. Alam natin na tangent squared 45 plus phi over 2 lang yung requirement niya for getting the passive earth coefficient. So, that means yung KP natin dito will still be the same as the previous sample problem. So, 2.0396. So, ngayon, ang maiiba lang will be how we can get the shape factor. So, let's start with the shape factor. So, that will be first yung lambda CS natin. The lambda CS is equal to 1 plus 0.2 kp B over L. So, hindi na kasi ito magiging 1.0 for this part kasi nga, this is a square. So, that will be 1 plus, that is 0.2 times the kp, 2.0396, times B over L. So, that is 3.5 over 3.5. So, this will be 1. So, from this equation, we have the lambda CS equivalent to 1.4079. Then, kunin natin yung lambda QS and yung lambda gamma S. So, that will be 1 plus 0.1 kp B over L is equal to 1 plus, so, substitute na natin 0.1. KP natin will be 2.0396 times B, 3.5 divided by L of 3.5, which is 1. So, our lambda QS and our lambda gamma S will be equivalent to 1.204. Now, we are ready to determine naman yung depth factors kasi magbabago din to. So, our depth factors will be, so simula tayo ng lambda CD. So, that will be 1 plus 0.2 square root ng KP dF over B. So, that will be equivalent to 1 plus, so 0.2 times a square root of 2.0396 times yung dF natin, which is 1.4 over B, which is 3.5. So that will be the lambda CD, which is equivalent to 1.1143. Next will be lambda QD and lambda gamma D. So, ang nagpapalit lang naman dito, yung 0.2 is nagiging 0.1. So, that will be 1 plus 0.1 square root ng KP dF over B. So, that will be 1 plus 0.1 times square root ng 2.0396 times 1.4 na dF divided by B, which is 3.5. So, our lambda QD and lambda gamma D coming from this equation will be 1.0571. And sabi ko nga, yung inclination factors natin, so yan yung lambda CI, lambda gamma I, and lambda QI will just be equivalent to 1.0. So, since nakuha na natin yung bagong shape at depth factors natin, ngayon pupunta tayo dun sa bearing capacity factor, which is hindi na din natin kailangan kunin kasi meron na tayong na-compute nyan from our previous video on sample problem regarding the continuous footing. So, yung na-compute natin dun is meron tayong NQ, which is equivalent to 6.3994. Meron tayong NC, which is equivalent to 14.8347. At meron tayong N gamma, which is equivalent to 2.8709. So, kailangan na lang natin siyang i-substitute sa general equation ni Meyerhof. So, yung QU doon will be equivalent to CNC, lambda CS, lambda CD, lambda CI, plus QNQ, lambda QS, lambda QD, lambda QI, plus 1/2 gamma B and gamma, lambda gamma S, lambda gamma D, and lambda gamma I. So, substituting to this equation, we will have yung C natin is 20 times NC will be 14.8347 times the lambda CS, which is 1.4079 times lambda CD, which is 1.1143 times 1, which is yung inclination factor, plus, so dun tayo sa Q, which is 112 over 5 times yung NQ, which is 6.3994 times lambda QS, which is 1.204 times lambda QD, which is 571 times 1. Then, yung ating last terms will be 1/2 times yung gamma natin, which is 2119 over 175 times 3.5, which is yung B natin, times 2.8709. So, that is yung N gamma natin. Then, yung lambda gamma D or gamma S, which is 1.204 times yung lambda gamma D, which is 1.0571 times inclination factor of 1. So, now, calculating yung mahabang equation na to, so much better para hindi magkamali. Store nyo to sa A, store nyo to sa B, then yung last term, store nyo sa C. So, getting those values and adding the values stored in A, B, and C, we will get a magnitude of 725.3313, that is in kilopascals. So, ito na ngayon yung sagot nung problem natin in item B for the square footing using the Meyerhof's bearing capacity equation. So that will be all for our sample problems regarding Terzaghi's and Meyerhof's bearing capacity equation, or for our topic on the ultimate bearing capacity for the shallow foundation. So again, this is Engineer Rodolfo. Thank you for watching, and don't forget to subscribe to Butch TV.